Our next lesson is called Simple Interest in Arithmetic Sequences. So a little bit of background. When you deposit money in a bank, the bank usually pays you for the use of your money. When you take out a loan from a bank, you have to pay the bank for the use of their money. In both cases, the money paid is called the interest. Simple interest is computed only on the principal. It is used commonly in variable rate consumer lending and in mortgage loans where a borrower pays interest only on funds used. Underneath, you will see the formula for simple interest. I equals PRT. The I stands for interest. The principal is P. R is the rate. It will be given to you as a percent, but you need to change it into a decimal. And the time in years is T. Looking at example 1, Raul needs $200 to start a snow cone stand for this hot summer. He borrows the money from a bank that charges 4% simple interest per year. How much will he owe if he waits 1 year to pay back the loan? So the first part of the question wants to calculate the interest. We are using the simple interest formula, I equals PRT. We will then substitute in everything that we know. We do not know the interest. That's what we're trying to find. The principal is the amount you borrow or the amount you put in. So our principal in this question is the $200 that he is borrowing in order to start the snow cone stand. We then have to plug in a rate. So our rate is 4%, but we need to change that to a decimal by moving the decimal place 2 places to the left. So as a decimal, that would be 0.04. That's going to go in for R. And then our time is 1 year, given right there in the statement. So we will put a 1 in for T. We can use our calculator to calculate that multiplication, and we will find out that the interest is $8. Now that's just the interest after 1 year. If he borrows $200, he would have to pay the $200 back plus any interest. So to calculate the total, you're going to take the principal amount of $200 and add the interest to it for a total of $208. In part B, let's continue to calculate the interest in total that Raul would owe if he waits 2 years, 3 years, and so on. We will organize our results into a chart. So we already did 1 year. Our interest was $8. And our total was $208. If we were to do 2 years, just think about the fact that that formula up top would be interest equals 200 times 0.04, but then you would be timesing it by 2. So that $8 would be $16 instead for a total of $216. That means after 3 years, if I were to write the same formula, and multiply those numbers out, I would have an interest of $24 for a total of $224 that I would have to pay back. And lastly, if I did it for 4 years, I'd have a total of $32 in interest for a total of $232. In question C, it asks, what type of sequence do you see? So you know out of the sequences we've learned, we have arithmetic and geometric. Arithmetic, we want you to think adding. Geometric, you think multiplying. So if I go take a look at what's happening within this table, to get from 208 to 216, I added 8. 216 to 224, we added 8. 224 to 232, we added 8. So if I was going to classify this as a type of sequence, I would classify it as arithmetic. In part D, write a formula for how much he will owe after T years. So we want to have a setup that will show us no matter what we plug in for the time, it will give us the total amount owed when done. So a formula we're going to write as a function. It's a function of time. The time will be put into the function for a total. Now think about what we did up top. In order to find the total, we have to find the interest, but then we have to add it to the principal amount. So our principal amount was $200. We have to pay that back no matter what. We also have to pay back 4% of that $200. So 200 times the 4% as a decimal, but then instead of plugging in a number for our time, we'll leave it t so that we can use it to find out for any time. If we were to simplify that, that would be f of t equals 200 plus 8t, and that has a similar setup to mx plus b. My rate of change or my slope is in front of the variable 8. You see that from the table. If I were to work my way backwards and find out what's across from 0, I would find out it was 200. Plus, I would know that from knowing 200 was the principal amount. Now in example 2, Raymond bought a car for $40,000. He took a $20,000 loan from a bank at an interest rate of 15% per year for a 3-year period. What is the total amount, interest and loan, that he would have to pay the bank at the end of 3 years? We are using, again, the formula I equals PRT. We're looking for the interest first. Our principal amount is the $20,000 loan that was taken out. That goes in for P. My rate, 15%, needs to be changed to a decimal by moving the decimal place 2 places to the right. So that would be 0.15. Our time, it was a 3-year period. We want it at the end of 3 years, so I will substitute in a 3. When we calculate that multiplication, we get $9,000. Now again, that's just my interest. They want to know the total amount, which they said is interest and the loan. So I need to take the principal value, what the loan was worth, and add the interest to it for a total of $29,000 that I would have to pay back when the loan is up. Now at this point, there's practice questions that follow. If you have been given an activity to do, at this time you would stop the video and complete the activity. If you have not been given an activity to do, you will do the practice questions right in the notes. You'll pause the video, try the problems on your own, and then resume the video when you're ready to go over the answers. So at this time, please pause and resume when you are ready. Okay, looking at the practice questions, number 1, Doug made a 3-year investment. The interest rate was 4.5%. After 3 years, he earned $675 in interest. How much was his original investment? We're using I equals PRT. This time, they gave us the interest. So we want to plug in $675 for I. We do not know the principal. That stays P. Our rate, 4.5%. You would move the decimal place 2 places to the left, which means we would have 0.045. And then we want to do this for 3 years. This gives me 675 equals. If I take the numbers and multiply them, I get 0.135 P. And in order to solve for P, I must divide both sides by the coefficient of P, which is 0.135. I would find out that my principal amount was $5,000. In number 2, Kim got a loan of $4,700 to buy a used car. The interest rate is 7.5%. She paid $1,057.50 in interest. How many years did it take her to pay off her loan? So I equals PRT. We know the interest is $1,057.50. We know the principal was $4,700. I'm going to take my 7.5% and change it to a decimal by moving it 2 places to the left to get 0.075, and I am trying to find out how much time it would take. So this is $1,057.50 equals, if I multiply those two numbers, I get 352.5 T, and in order to solve for T, I need to divide by 352.5 on both sides of my equation. So I would see that my time is 3. So it would take 3 years to take care of that loan. And then lastly, practice question 3. You borrow $6,000 from a loan shark. If you will owe $7,200 in 18 months, what would be the simple interest rate? So we're still starting with I equals PRT, our formula. We're going to plug in what we know already. Now this one takes a little bit of thinking here. You borrowed $6,000, you end up owing $7,200. So you need to figure out what your interest was. $7,200, you would have to subtract the $6,000 you took out to see that your actual amount for your interest would be $1,200. That's going in for I. My principal amount I know was $6,000. My rate, we are not sure what it is, but I know I'm doing it for 18 months. So we have to talk about what that means. We are not allowed to plug time in as months. If you go back and look at the original start of the lesson, time has to be in years. So 18 months in years, there's 12 months in a year, that's another 6 months. This is going to be 1.5 years. So we want to put a 1.5 in for T. So we would have 1,200 equals 6,000 times 1.5 is going to be 9,000, R. We would divide both sides by 9,000 to get the variable alone. And we find out that the rate is 13 1/3%. And that concludes your lesson on simple interest and arithmetic sequences.